Remember how we looked at standard enthalpy of formation? There's also standard Gibbs energy of formation. Now, again, just like the earlier case, you will be given an equation. You have to make sure the equation is balanced. If not, you have to balance it. Again, you do not have to remember the generic equation, which is delta G0F of products minus delta G0F of reactants. Keep in mind, this does not include the coefficient. This is generic and the reason I'm doing this is something I can easily write and explain instead of spending a colossal amount of time writing the generic equations. It's much more simpler to write. And now let's go to the equation. We see clearly this needs to be balanced. So this is 2NO. So this is 1 and 1. So that's important that you take care of that. Now you come back and solve for delta G0F, which would be, you do not have to memorize these. These values will be given to you. It's products minus reactant. There's only one product, which is NO, and that is 173. So it's 2 times 173 minus, I close the bracket, finish off products completely, minus, do it for each reactant. It's 1 times, it's not 2, sorry, it's 1 times. N2 is 150, and N2 is 123.5, close the bracket, plus 1 times oxygen is 155. Close the bracket, do the math, and that's the end of the problem. I mean, I don't really see how this is even difficult by any extent compared to, I mean, answer minus 123.5 plus 155. So it's 67.5. Do you think this is exothermic or endothermic? I mean, do you think this reaction is spontaneous or non-spontaneous? Think about it. No sign means it's positive. And I said if delta G0 is positive, means it's non-spontaneous. And if it is negative, means it's spontaneous. Clearly, this value is positive, so it's non-spontaneous. Even though that's not the question, I just like to go a little overboard with my solutions. So that's non-spontaneous, but this is all the question is asking for. It should be kilojoules. And that is it. So you have one equation, one generic equation like this for enthalpy. Don't confuse this with the bond energy. This is slightly different, but they all work very much the same way. All right, I got one more problem and we're finishing up thermodynamics, so stay tuned.